Hello and welcome to my video 3.1 based off of the Math Makes Sense 9 textbook. This is classifying and comparing rational numbers. So first of all, we're going to just talk about what different types of numbers there are, and we'll talk about a couple of the terms, and then we'll give some examples, and then we'll start comparing numbers. Alright, so first of all the numbers that you've probably seen at this point in your life, we call real numbers. They're not fake news, they're real numbers. But there is the other category which I'll talk about at the very end, but so far in your life, you've probably only seen real numbers. But within real numbers, there are different categories. There are rational numbers, and there are irrational numbers. So there are these two sections, and first of all we're going to talk about irrational, and then we're going to go into rational, and then go into a little bit more depth. Irrational numbers are related to those imperfect squares. Any of those would be an irrational number, which is compared to from topic 1. So imperfect squares, basically any number that ends up having decimals that just don't repeat ever. Okay, it's just random numbers, seemingly random numbers going on to infinity. There's a couple classic examples like pi, which is 3.141592 ... and just keeps going. Or e, which is a ratio number that has to do with integration and differentiation, so you don't know about it yet. And of course, any sort of imperfect square. So the classic one is square root of 2. But that could be any option as well. And it could be a negative outside of whatever, and that'd be fine as well. Now, rational numbers are numbers that have decimals that stop. Okay? Any number that has decimal that stops, see it ends, or numbers that have decimals that repeat, those are rational. So first of all, another way to look at it is anything that can be shown as a fraction. So this can be shown as a fraction, 345 out of 1,000. So any decimal can be shown as a fraction. Repeating decimals are a little bit harder, but there is a way. There's always a way. So that's 1/3. Other examples would be just other fractions, but they could be negative as well. Also, it doesn't have to be a fraction or a decimal. It can be a whole number, or bigger than a fraction. So like, let's say 8 over 3, okay? Or let's over 5 because we already have 3. So it can be bigger than one whole number, or if it is a whole number, it can be that as well. So let's say it's 2. 2 is also a fraction, 2 over 1. So it's still rational, okay? But within rational numbers, there are subcategories, and we'll start with this one because it's the next subcategory of number, integer. So integers include any whole number or any like full number from negative numbers, -3, -2, -1, to 0, including 0, and then it counts up from there. Okay? The next category is called whole numbers, which starts at the 0 mark and goes up. So that's 0, 1, 2, 3, and etc. And then lastly, we have natural numbers. Natural numbers, which start at 1 and go up. So we have 1, 2, 3, etc. So, as you can see, each of these categories includes some of the stuff before it. So let's say here. Oh, I should put this in red. Okay, all of the categories have something from the one before it. So they're not just on their own for those from rational to integer to whole number to natural. They're not just on their own. They include some of the one before it. But when you're asked to classify something, usually you go with the most specific. So if it is a natural number, it's one of those. Okay, if it's one of those, it's a natural number. If it's 0, it's a whole number. Maybe I should stick with black. So natural number, 0, it's that one. If it's a negative whole number, it's that one. And then fractions and decimals, we usually call rational. Okay, but rational actually includes a lot more than that. Okay, but we're going to look more specifically now when we're comparing rational numbers. We're going to be comparing fractions and decimals. So we're going to be looking at more so this side of things and less the integer side. One last thing I want to say before we move on is that we can have real numbers, but we also have imaginary numbers. Imaginary numbers. So imaginary numbers are a wacky set of numbers. They are the opposite of real numbers. So instead of having the negative, let's say right here, outside of the brackets, what if we had the negative inside the brackets? Square root of -1. That is I. That is the imaginary number. And then it can be used in multiple cases. Square root of, like, let's say, -2 is equal to square root of 2 times I. So anything with I in it is imaginary number. Now that's beyond what we need to know at this point, but that is there for you to know about. I just want to future-proof this. Okay, so we're looking at a couple fractions, and we need to try to compare them. So let's say we've got 2/3, and we have 5/9. How do we know which one's bigger? Well, we need to get a common denominator. That means we want to get, here we can use this, we want to get these bases to be the same number. So what we're going to do is we're going to have, we're going to make sure that the bottom number is the same. Now what you might notice right away is if we multiply this whole side by 3, the bottom number is going to be 9. So let's do that right now. So 3 times 3 is 9. 2 times 3 is 6. And we already have the lovely 5/9 on that side. So now if we compare the two, we can see that 2/3 is bigger than 5/9 because 6/9 is bigger than 5/9. Okay, fairly easy. All we have to do is multiply one side, so it makes it nice and simple. Now, a little bit more complicated of an issue is a decimal one, and more complicated even than that is what it's going to look like in a bit. So here, a decimal one, it's easy to switch into a fraction, but it's not necessarily the most simple fraction. So this is in the tenths place. Tenths. Which means that we have 4/10. That's another way of writing it. Tenths. 4/10. 4/10. Okay? And we have the 3/8 over here. Now, 4/10 is actually not very simple. We might see right away that both are divisible by 2. Both can be divided by 2. So I'm going to divide by 2 right now to give me 2 there and 5 there. So 2/5 comparing to 3/8. Oh my goodness, they're not the same. The bottom denominator is not the same. So let's try to make them the same. Now what we're going to do to make them the same is we're going to multiply the 5 by that whole side. And we're going to multiply the 8 by that whole side. So then we will have 8 times by 2/5, and we will have 5 times 3/8. Okay, so if we're multiplying it by a fraction, like a number by a fraction, we have to actually look at it as a whole thing. So 8 times 2 is 16. 8 times 5 is 40. So we need to multiply by the top and the bottom. Oopsies. And then same thing on this side. 5 times 3 is 15. 5 times 8 is 40. And now we can compare them, and we can say 16/40 is bigger than 15/40, which means that 2/5 is slightly bigger than 3/8. So hopefully this video helps you understand how to simplify and make common denominators, and also how to classify and compare rational numbers. Good luck, and thanks for watching.